Hey there! Welcome to Power Process Electrical Engineering Tech. Today we will know type of controllers in control system. First, make sure you subscribe and like the video. In control systems, there are several types of controllers that are used to regulate and manipulate the behavior of a system to achieve desired performance or stability. The choice of controller type depends on the specific application and the characteristics of the system being controlled. Here are some common types of controllers. Proportional P controller. A proportional controller provides an output that is proportional to the error signal, which is the difference between the desired set point and the actual process variable. It is the simplest form of controller and is often used when precise control is not required. Integral I controller. An integral controller eliminates the steady-state error by integrating the error signal over time. It continuously adjusts the control output based on the cumulative past errors. It helps in reducing the offset between the set point and the actual process variable. Derivative D controller. A derivative controller predicts the future error by considering the rate of change of the error signal. It responds to the rate of change of the error and helps in reducing overshoot and damping oscillations. Proportional integral PI controller. A PI controller combines the proportional and integral actions. It is one of the most common types of controllers and is used to improve both transient and steady-state responses. Proportional derivative PD controller. A PD controller combines the proportional and derivative actions. It is often used when there is a need to reduce overshoot and improve damping without eliminating steady-state error. Proportional integral derivative PID controller. A PID controller combines proportional, integral, and derivative actions. It is a versatile and widely used controller that can provide good control in a wide range of systems. Proper tuning of PID parameters is essential for effective control. Lag compensator. A lag compensator is used to improve the steady-state accuracy of a control system. It introduces a phase lag in the system, which helps in reducing the steady-state error. Lead compensator. A lead compensator is used to improve the transient response of a control system. It introduces a phase lead in the system, which helps in reducing settling time and improving stability. Lag lead compensator. This is a combination of lag and lead compensators, used to achieve a balance between steady-state accuracy and transient response. State feedback controller. State feedback controllers are based on the state space representation of a system. They use information about the system's internal states to compute the control signal. They are often used in modern control systems. Nonlinear controllers. In some cases, nonlinear controllers, such as fuzzy logic controllers or adaptive controllers, are used to control systems with complex and nonlinear dynamics. Optimal controllers. Optimal control techniques, such as the linear quadratic regulator, LQR, or model predictive control, MPC, are used to optimize a control system's performance based on a cost function. The choice of controller type depends on the specific requirements of the control system, including desired performance, system dynamics, and control objectives. Controllers are typically selected and tuned to achieve the desired control behavior in a given application. Thanks for watching.